The town of Fairmount, Indiana is well known as the childhood home of actor James Dean. The town continues to be featured and visited for its relationship to the famous actor, but maintains its status as a small town in Middle America with only approximately 2,800 residents. Maintaining and updating infrastructure for a small number of residents doesn't mean it comes at a small price tag. Like many towns and cities with older sewer systems, Fairmount has a combined sewer system and faces some of the largest number of wet weather sewer overflow events in the state. With about 60 overflows annually, this is a threat to the health and safety of local waterways and the general population.
We're known for James Dean and Garfield, but we're also have the most CSOs per capita of anybody in the state. We have got really only a couple of dedicated stormwater lines, and the rest of our system is combined sewer, so we treat everything. Everything comes out here. The state is trying to get us to less than 10 overflows through our combined sewers on a yearly basis.
The Indiana Department of Environmental Management has required the town to develop a long-term control plan to address these issues.
And they said we had $30 million worth of work to be done trying to tighten up sewers and put new sewers out, and this is all supposed to be done in the next 20 years.
Achieving compliance status with the state mandates at a reasonable price tag to ratepayers is no easy feat. The town must apply for grants and funding to help offset these costs.
With our rates going up and where our median household income is, we'll be able to apply for more grants.
Right now, the town is working on a component of the long-term control plan, a wastewater treatment plant expansion project.
This is just one of about 20 projects to start.
The intent of the wastewater treatment plant project is twofold: to update the more than 30-year-old facility, replacing dilapidated equipment to treat wastewater to current-day standards, and to provide facilities necessary to manage increased flows associated with wet weather events, reducing the number and frequency of CSO events. Commonwealth Engineers was hired by the town in 2013 to review the original wastewater treatment plant improvements project design and offer cost savings and constructability solutions. Commonwealth also aided in the coordination with the U.S. Department of Agriculture's Rural Development. This project consists of construction associated with the following facilities and equipment.
This is where all the water comes into the plant. This has got a grinder on it that has not been operational for a couple of years, and we're going to a fine screen, and most of the guys can hardly wait to get that in here because we do have to go down here and clean screens and put them in buckets and then carry it out. The pump station was going to be expanded because of the soil and water conditions out here. We have changed it thanks to Commonwealth. Brainstorming through Eric and Al and myself and Bud, we think we've come up with a decent change and cost-saving measures for this. We're utilizing what was an old dry well pump station, or a dry well setting for the pumps downstairs. We really wanted the submersibles, but I think that this dry well setting will be much better off for us. The building that's under construction, that is grit removal, alum treatment. Pumps will pump from here to the front of the building near where the scaffolding is, and the pipes will come up in that middle structure. And a lot of the solids, a lot of the sand and grit, cigarette butts, plastics, anything that comes into the plant will be taken out there. And then this building here to the left of that is chemical feed for alum addition. We drip alum into the waste stream to take out the phosphorus. After the water gets pumped up, this will be where the water gets degritted. It'll get a flow measurement coming in, and it'll come down here, and it splits and goes to these two oxidation ditches. The ditches were put in 1983. And as you can see, we've lost some of the stars off of the rotors. They're still doing a pretty decent job as far as adding oxygen and getting treatment. However, I can hardly wait to get the new rotors in. These are mild steel and the new ones are stainless. We got 2 new circular clarifiers going up over here that's going to take the place of these. The circular clarifiers are pretty much a staple to the industry. I could hardly wait to see those go. This is one of the new 45-foot clarifiers. Mixed liquor comes into this tank and then it settles. It comes in through the center, it overflows a weir, and then it settles and then it comes to the outside. Header in the bottom takes the solids that have settled down, sucks it up and pumps it back to the influent of the oxidation ditch. Then the clear water comes out, overflows here, goes out over there, and then it heads over to where the traveling bridges are to be disinfected.
But right behind that formwork there is the wet well for the sludge pumping station. And that's where all the sludge comes off the bottom of the clarifiers into that wet well. And there's 2 submersible pumps in there that pump the sludge either to the sludge thickener tank up there or back to the oxidation ditch.
Kind of standing in the new sulfur dioxide chemical feed room right now. We do not dechlor. Right now we've got our ponds that have done dechlor and done a very good job of it since the time that they were put in 1983. With moving more water, we can't use the sunlight and the detention time in the pond out front to do our dechlorination, so we get a new sulfur dioxide room here.
The work also includes miscellaneous flow diversion and metering structures, plant access drive, paving, yard piping, process piping, demolition, excavation, dewatering, regrading, site restoration, coatings, electrical, HVAC, instrumentation and control, and general site cleanup.
This will be the end of our stormwater treatment. This holds about 1.2 million gallons of water. As the flow picks up, it'll go through the grit structure, the grit will be taken out of it, and then it goes through a big pipe that flows down to the opposite end of the pond here. And the water settles out here, and whatever settles will settle out into this, and then the water discharges over here through this structure, it gets re-aerated, has to go out to the creek with more than 6.0 milligrams per liter of oxygen in it. With high flows with us, this plant started out at 0.55 MGD, and at peak flow this plant is supposed to be able to treat 3.5 MGD. So it's expanding about 6 times because of the storm water and the combined sewers.
Commonwealth's value engineering efforts provided approximately $300,000 in deductive bid items. Additionally, Commonwealth was able to coordinate an extra $200,000 in grant money, netting an overall savings to the town of $500,000. With communities like the City of Indianapolis facing projected $100 to $125 sewer bills as a result of their long-term control plan work, the town can be proud of their elected officials' diligence in minimizing project costs through both value engineering and the maximization of available grant funds. Moving forward, the town will monitor the effectiveness of this improvements project, update their sewer model to reflect this new facility, then revisit the remaining work identified in the long-term control plan and determine the most cost-effective next steps in solving the town's combined sewer overflow issues.
We will not end up with many solids going out to the creek, so the creek bottom won't be soft, and we'll see a few more aquatic life, fish and frogs and things, back up in the stream. We're kind of put on this earth to be good stewards of the earth, so one of these days our kids will see benefits from it.